Picture an entity sitting in a chunk of memory, packed tightly next to every other entity that has the exact same set of components: position, velocity, nothing else. Now you add a health component to that one entity. The instant you do that, its component set no longer matches the chunk it's living in. It has to leave. That's the entire problem I'm solving today. What happens, mechanically, when you add or remove a component from an entity in an archetype-based ECS? The core idea is simple, and I want to say it once clearly before we get into the edge cases. In Xynok ECS, every unique combination of components defines an archetype, and every archetype stores its entities in chunks, contiguous memory, packed for fast iteration. So when you change what components an entity has, you're not editing that entity in place. You're moving its entire row of data out of the chunk it's currently in and into a chunk belonging to a different archetype, the one that matches the new component set. Simple concept, messy in practice, because add or remove a component isn't one operation. It's several, depending on what state the entity is already in. If you're adding a component, the entity either already has it or it doesn't. If you're removing one, same thing. It's either there or it isn't. Get sloppy about which case you're in, and you'll either silently duplicate data or crash on data that was never there. So instead of one catch-all method, Xynok ECS exposes exactly three: add, merge, and remove. Let's start with add. Add control in my library has one hard rule. The component you're adding must not already exist on that entity. If it doesn't, here's what happens under the hood. The entity's full row of data gets copied out of its current chunk and into a chunk in the target archetype, the archetype matching the old component set plus the new component. Once that row is gone, the slot it left behind in the old chunk is empty, and an empty slot in the middle of a packed chunk is exactly the situation you don't want. So I close the gap with a swap. The entity currently sitting at the very last index of that chunk gets moved into the newly freed slot. There's exactly one exception. If the entity we just moved happened to already be the last one in the chunk, there's nothing to swap. The chunk is just one shorter and we're done. Now, what if you do want to add a component that's already there? Say you're re-adding velocity with a new default value, instead of touching a component that's genuinely new. Add won't let you. It'll refuse if the component already exists. That's what merge is for. Merge behaves exactly like add for any component that's new to the entity. Same move, same swap, remove, cleanup. But for any component that already exists, merge doesn't move anything. It just drops the old value in place and writes the new one over it. So merge is really add's more permissive sibling. Everything new gets migrated across archetypes. Everything that already exists just gets overwritten. Remove is the mirror image, with one important difference in how it fails. Where add refuses to run if the component already exists, remove goes further. If you try to remove a component the entity doesn't have, it panics. No silent no-op, no returning false. That's a deliberate choice. Removing something that was never there is almost always a bug in the calling code, and I'd rather find out immediately than have an entity quietly end up in the wrong archetype 3 systems downstream. Mechanically, remove does the same thing add does, just in reverse. The entity's row moves out of its current chunk and into a chunk belonging to the archetype for the component set, minus whatever you removed, with the same swap remove closing the gap it leaves behind. There's one case worth calling out specifically. What happens when you remove every single component an entity has? You'd think that entity falls out of the system entirely, but it doesn't. It lands in an archetype defined by an empty component set. And in this codebase, an archetype with 0 components is still a fully valid archetype. It has a chunk, it has a slot, the entity still exists, it just doesn't carry any data yet. That one detail is what lets add, merge, and remove all stay the same 3 operations, no special case required, all the way down to an entity with nothing on it at all.